Let's see. Okay, it's recording. So first of all, let's talk about TCP. When you establish a TCP connection at the beginning, there are 3 packages that are exchanged between the client and the server. And this is called a 3-way handshake. So in the first segment, the sync flag is going to be on. In the second segment, the sync ACK flag are going to be on. And in the third segment, only the ACK flag is going to be on. So we call this sync ACK ACK, which means that, let me write it here. So first segment, we will have the sync flag on. In the second segment, we'll have 2 flags that are on, the sync and the acknowledge flag. And in the third segment, we will have the ACK. This is the way that TCP establish a connection. And to finish a connection, TCP use a fin flag. So end of connection can be, for example, FINAC, ACK, FINAC, ACK. So we have a segment, let me call it X, that will be fin plus ACK, fin for finish. Then we will have another that will be ACK, then another FINAC, and then an ACK. So this is a way to close. So that will be segment X, that will be segment X plus 1, X plus 2, and X plus 3. So this is not the only way to close. We can have FINAC, FINAC ACK. So we can see that also, what I'm going to write. FINAC, FINAC ACK. And when a port is closed, what we are going to see is 2 flags, sync and then reset ACK. There is a flag that is called reset. Okay, so let's capture some traffic and see those flags. So I'm going to do a small lab. Let me create a new lab that I call TCP01. So we can explain TCP. So in this lab, I want 2 PC and I want 1 PC to offer a service. So let me give us access to the cloud, to the internet. Let me put a switch so both can be connected to the switch. Okay, I'm going to connect the switch to the internet, so we have access to the internet, and I need 2 PC. So let me take 2 PCs, 2 Debian 7, for example, to 2 Debian 8, 10. So we have a last version. So this one, let's call it client. And the other one that I'm going to copy, let's call it server. So we can do a connection between them. And in the server, I'm going to install some services. Let me change the icon so we can see it's a server. So I go here and change symbol, classical symbol, and I'm going to find a PC that looks like a server, like this one. Okay, this is just a representation, so it's make it easier to understand. So I'm going to start both of them. The client, the server. Okay, so let's see, the client is booting. The server is booting. Okay, the client has finished to boot. So I'm going to enter as an administrative user. Let me call it client. So it's a little easier to understand what I'm doing. Let me exit here and come back so we see client. Okay, it's client, and this guy is going to be the server. So I want to get rid of the default name that say Debian. So with the command hostname, I'm going to specify that the name is server. And to see it reflected on the prompt, I have to go out and come back. Okay, now you can say server. So here I want to install a server. For example, what server can I install? A telnet server? Let's install a telnet server. So before I do it, a good recommendation is that you update the list from the repository. So we get a fresh list of software that are available in the repository. Okay, because maybe the last time that I did that, it was a long time ago. Then we are going to install, for example, the telnet daemon. Okay, and we have only one user, it's okay. We have the user Eric, it's enough to do. Otherwise, we can add some user. You know the command to add user, no? If I want to add a user, I type, for example, user add. Let's say that I want to add a user that is called John, let's say McDonald. So I can add John. Let me use, let me remove the user. I already user del, and let me use the other command. So add user, which is a command that will ask me the password of John. Let me put John pass, John pass, the full name, let's put John McDonald. Everything is okay. Okay, we have another user. We have 2 users in the server. And we might see with this command if port 23 is open. As you can see, it's open. So we have a telnet server. So we can telnet. So before I telnet, I want to capture the traffic. So we see the sync ACK. So for example, here, I'm going to capture the traffic, and then I'm going to telnet, and you will see the sync ACK that I'm commenting here, sync ACK. So let me do telnet on the IP address of the server. I need the IP address of the server, so I'm going to ask the server what is its IP address. So this is the IP address of the server. So let me just copy it so we don't have to type it. Okay, so look, Wireshark, and look at how we will see the 3-way handshake as soon as I type that. So I type it, and we have a lot of telnet packets that appear. So let me end the connection. Quit, so we can see the end. Oh, I didn't end it. Yeah, maybe it's better to wait the timeout. Yeah, still on. So let me enter. What is the user? Me. Okay, the user. Let's put John, for example. And John pass. And let me. I am in the server in this moment as John, and let me exit. Okay, so we have an end of connection and we have a beginning of connection. Let me stop. So let's go back to the beginning. So look at the first packet. This packet goes from the client to a server. I have the sync bit on, as I was telling you. Then the second packet, I have sync ACK. It goes from the server to the client. Then the third packet that goes from the client to the server, I have the ACK bit on. So this is the way that we establish a connection. This is called a three-way handshake. And the way that we finish a connection, I did finish a connection also. Let's see it here. For example, here we have a FINAC, FINAC, ACK. You remember I told you it can be FINAC, FINAC, ACK. And here we have a FINAC, FINAC, ACK. So the client sent to the server a FINAC. The server, which is finish, I want to finish. The server confirms that he wants to finish also. And then the client say, okay, we are done. So it's a way that we will close a connection. And for example, let me now show you if the port is not open, what will happen. For example, let me start capturing again to a port that is not open. So for example, the port 80 is not open. We don't have a web server in the server. We have a telnet server. So we will see sync reset ACK. It is there. Sync is when the client contact, let me stop the capture. The client contact the server on port 80 saying, I want to start a connection with you. So if the server do agree, the server is going to answer with a sync ACK, and then the client with a ACK. The server did not agree because the port is not open. So the server answer reset ACK. I'm telling you to reset this connection. I don't want this connection with you. Why? Because my port 80 is not open. I do not have a web server. So the server just answer with a reset ACK. Reset this connection. I do not agree to start a connection with you. Okay, so this is a small introduction to TCP. We know that TCP has some flags. This is what I wanted you to understand. And some firewall are called stateless firewall. When a firewall is stateless, it means that it takes its decision only with the information of the packets. So it's not advanced firewall, it's a very basic firewall. It's not, we cannot configure advanced rule. We cannot set up advanced rule in a stateless firewall. Now, all the firewall are stateful. For example, IP table is a stateful firewall. What does it mean that it's a stateful firewall? So you can take decision on a packet not only with the field of the packet, but also you can relate the packet with other packets and take a decision based also on the relationship between this packet and other packet that you received previously. So a stateful, which maintains state, is much powerful and allow us to write much more advanced rule in the firewall. So we are going to see it today. We are going to see stateful firewall. So before we do that, let me introduce you a module that we have in IP table, which is the module here, the one that we are going to study. The module that have information about state. So a stateful firewall, as I was telling you, is much powerful than a stateless firewall because it has the ability to maintain state information about the connection. So it's able to, when you receive a second packet, for example, when you establish a connection with TCP, you have three related packets, sync, sync, ACK, ACK. So it's able to relate the sync ACK with the sync and the ACK with the previous two ones, sync, sync, ACK, ACK. Is able to do that. So it's much powerful. So as you can see here, they say stateful firewall are more secure than stateless firewall. Remember that stateless firewall only take decision on the field of the packet. So it's very poor as a firewall. So with stateful firewall, you can accept or drop packet based on the relationship that the packet have with previous packet that were received. And as I was telling you, IP table, which is a front end of NetFilter, is a stateful firewall, which means it's very, very powerful. So there is a module in IP table that is called state. And this module allows you to track connection. So for example, it have a way where you can express the creation of a new connection. So what will be a new connection? For example, when you establish a connection through TCP, so there is this three-way handshake, sync, sync, ACK. The sync segment will be the first segment, and it establishes a new connection. So for example, you can drop the sync segment. You can say, I don't want this segment. If you drop the sync segment, there is no way that a TCP connection takes place. Now, what is an established packet? An established packet belongs to a connection that was previously established. So it's part of a communication that is already started, and it's one more packet of the connection. So for example, the second packet of the three-way handshake is an established packet. The third packet and all the other packets are established packets. When you start, when you run the ping command, the first ICMP echo request will be a new connection. Now, the ICMP echo reply will be an established connection because it's the answer of a previous packet. Established is that, okay, we already established the connection and this is related to previous packets. So related. So some protocol do open several ports. For example, FTP. FTP have two connections, a command connection and a data connection. So at the beginning, you only open the command connection. And at one point, you open the data connection. For example, when you transfer a file, when you download a file, which means from the server to your client, or when you upload a file from your client to the server. So it's a related connection. So related allow you to permit or to drop related connection. Invalid. Invalid is a packet that I cannot relate with previous packets. So a good practice in general is you better drop all the invalid packets, because there might be packets that a hacker tried to send to see if you have any weakness in your system. So you better drop them. You should not have invalid packet. They should not be there. If there is a packet that arrives, it has to be a packet for a new connection, or it has to be a packet for an established connection, already established connection. But packets that have no relationship with previous packets that are new connection are suspect. So you better drop them. Okay, let's see, for example, this rule. What this rule will do. So as you can see, I am appending in the chain input. So for input packets, I am appending a rule. And this rule is based on the state. The state have to be established or related. And I will accept them. So what do you think this rule will do? So for established connection, it will accept the packet that come after the first packet. Okay, the thing that is important is the first packet that establishes a connection, then you have the related packets. If you accept the connection, you have related packets that come after, no? And you can, for example, accept them. If you accept the first one, you should accept them, because if you accept the first one, the one that creates a new connection, is that you are willing to establish the connection. So all the packets that come after, which are the established packet, you should accept them. And if the protocol open another port, that will be the related packet, you should also accept them. Otherwise, you don't want the communication. Okay. Let me explain you other things that you can do with IP table. With IP table, you can also filter by time and date. So for example, you can say a service is open from 8 a.m. in the morning to 6 p.m. in the afternoon. So we have a module that is called time. So dash M is to say I'm going to use a module. And we have option. For example, the start date. So dash dash start date, you can put a date. So if you put a date, you will put the year, dash the month, dash the day. You can have a stop date. So for example, you can say that the service will be open from March 25 to, for example, April 20. So you can set a starting date and a stopping date of the service. So you can filter. So if you are not within the range, you don't permit traffic. Now you can also filter on the time in the day. So if you filter on the time in the day, you have to specify the time like that. Hours, colon, minutes. And the time will be in military time, which means that we will talk from 00:00, which is midnight, to 23:59:59, which is 1 second before midnight. It's late in the night, no? From early in the morning to late in the night. So we will have a time start and a time stop. Now, you can also specify day in the month. Let's say that you want to allow the service only on the 1st and 15th of the month. So you can specify here with dash dash month day, you put a list 1,15. So you specify that the 1st and the 15th, you do agree either to accept or to drop the packet. And you can also specify weekdays. For example, Monday, you will write capital MON. Tuesday, you will write capital TUE. Up to Sunday, that will be capital SUN. So you can specify the weekday that you want the service to be available, so you will accept it, or you want to drop it. You want to block it. Okay, by default, all the time are specific to UTC time. Do you know what is UTC time? The universal time. So the universal time is the time that we have in London, the Greenwich Meridian time. So here we might be -6 hours, something like that. It depends. Sometimes we are -6, sometimes maybe we are -7. Is it that? Yeah, so it depends. So if you want to do it with the local time, you can use the option dash dash kernel time zone. So you want to use the local time zone. For example, here we are in central time zone, and we don't want to use the Greenwich Meridian time, the one of London in the UK, you know? It's called also the Zulu time. We don't want to use the Zulu time. We want to use our time zone, which is the central time. Okay, so with that, we will be able to do some exercises. So let me show you a first exercise that I would like to do with you. You open a terminal, put it bigger. Okay, I have a bunch of exercises here. Let me select one. Okay, exercise 1. So I just want to see this. So let's see how we resolve that. On the local machine, let's say that on the local machine, you have IP table running. You want to accept secure session only from the remote IP, this one. What can you write? What rule can you write to solve this situation? So we might do an example after. So do you understand the question? We have a server. On the server, we have IP table installed. It have a secure shell server running. The server have a secure shell server running. And we want to allow secure shell session only from this remote IP. What should I write? What rule should I write? What do you propose? So first of all, we always need to identify, is this input traffic? Is this output traffic? Or is this forward traffic? So what do you think? This is input traffic. So I'm going to append at the end of the input chain a rule. So the rule have to allow secure shell traffic, incoming secure shell session only from the remote IP, which is 192.168.0.20. So what should I write here to allow that? Only from this IP address, which means that from any other IP address, I want to drop the possibility of doing a secure shell session. So we'll need to specify what? So remember, what are the possibility of option when we specify the information of packet? For example, -s is for what? To specify the source. Should we specify the source? Yes, we need to specify the source because we want to allow this IP address. So I'm going to put -s. So I want to allow the IP address 192.168.0.20. So -d is to specify the destination. Do I need to specify the destination here? So the destination is already specified because it's an input traffic toward me. So it will have one of my IP address. So if I have several IP addresses, that's okay. I don't have to specify my IP addresses. You understand? Because it will be traffic that go toward me because it will enter in the input chain. So I don't need to specify the destination. If you do specify the destination, you have to put all your IP addresses. You might have only one IP address, but if you are a router or you are, for example, a server with several network interface card, you may have several IP addresses. So I'm not going to specify the destination. What else we need to specify? This is layer 3 information. Now let's go to layer 4. What can we specify in layer 4? The protocol that we want to use. Give me some options for protocol. TCP, UDP, ICMP, correct. So secure shell use what? TCP. So I'm saying that in layer 4, it have to be TCP. Now, TCP, remember, with TCP, we have many services. For example, if we use HTTP, the port is 80 or 443. If we use, for example, Telnet, the port is 23. We just saw it. If we use Secure Shell, the port is 22. If we use, for example, SMTP, what will be the port? Simple Mail Transfer Protocol, SMTP. The port will be 25. If we use, for example, FTP, File Transfer Protocol, the port will be 21. So if I just say all the TCP, I'm going to allow all the TCP. So I'm going to allow web services, I'm going to allow Secure Shell. This is what I want to allow. I just want to allow Secure Shell. They didn't say allow all TCP services. So I need to specify a port. So there are two options when you specify a port. You have the option destination port and you have the option source port. What should I use here? Destination port or source port? Because I want to allow the secure shell access in the web server that runs locally. This rule, I'm going to type it in a local machine. And in this local machine, I want to allow secure shell access from the IP address 192.168.0.20. So what should I type? -- source port or -- destination port, or maybe both. So what do you think? We need to type what? Yeah, of course, -- destination port. So what should we write here? 22, of course, because we want to allow from this IP address, we want to allow secure shell. So, of course, if this machine connects to us through secure shell, it's going to use that as destination port is going to use 22. Okay, what else should I write here? Very good, I need to accept it. So the action is specified with the -J option, J for jump. I'm going to accept it. Okay, so what will happen if I just type this? If a machine have a different IP address, will this machine be able to secure shell inside the server? If I just type that. So the machine is up, I just install IP table, and I type this rule. What will happen? Any machine will be able to access the the secure shell server. Why? I need to specify the other IP address, you need to drop it. I didn't specify that. So what will happen if I just do that? On a machine with another IP address, secure shell in the local machine, what will happen? It will go I only have one rule. It will go in this rule. Will the packet do a match or it will be a miss? When the packet of another machine that try to secure shell on the local server arrive, it will match the rule or it will be a miss for the rule. Let's say that I have a machine, my machine its IP address is 192.168.0.100. And I try to secure shell to this server. What will happen when my first packet arrives to the server and go through the IP table rules? What will happen? So this rule, will my packet match or it will not match? It will not match. So since it doesn't match, what will happen? It will look for a second rule. Do we have a second rule? It will go over the rule one at a time until one match. And when one match, it takes the action. So it's go the first rule, it didn't match. I look for a second rule, there is no second rule. So I'm out, there is no more rule. When there is no more rule, what should I do? I apply the default policy. And what is the default policy? Accept all traffic. So what will happen? They will accept my traffic, not because of this rule, because of the default policy. So what should I do? I need a second rule. So I need a second rule. So help me with the second rule. What should I put as a second rule? I need to open in the input chain a second rule so that any other IP address, I will drop the traffic of it. So what should the second rule say? I can do that. That's fine. I can do 0.0.0.0/0, then -p TCP -- drop destination drop, destination port, sorry, destination port 22-J drop. So let's see what happened now. Let's say that my IP address is 192.168.0.100, and I want to secure shell into the server that have this rule. So will my packet match the first line, the first rule? If my IP address is 192.168.0.100? No. Will my packet match the second rule? Yes. My packet is going to match the second rule. And the second rule say what? Drop the packet. And then I'm done. I don't go to the third rule. I already dropped the packet. So drop is a final decision. You drop the packet and you don't do anything, any more process on the packet. You just drop it. Some actions are a little more complex. You do several things. But drop is you drop it and you are done with the packet. You don't want to listen more about the packet. So now this will work. Now, there is another possibility. Can somebody tell me what can we do that will be very similar to what we just did, that will do the same work? So the second rule, we can make it a little different. We don't need to write this. We can just write that. Do you understand why? If we don't specify the destination, the source, sorry, it will be any source. When you don't specify the source, it's any source. So you don't need to say any source. So the first two rules, or these two rules are okay, or these two rules are okay to solve the exercise. Okay? So let's see how I can see that I didn't make any mistake. So we have a small lab here. Tell me how we can verify that the rule that we just specify are the correct rules. So let me add another client. So we have a server, and in the server, we need a secure shell server. So let's install a secure shell server. So I'm going to do apt-get install open SSH server. It will install the secure shell server. So once I install the secure shell server, port 22 is going to be open. Since port 23 was already open, we will have two ports that are open, 22 and 23. So look at the telnet is open, and now the 22 is open. So we do have a secure shell server running in this machine. So we have a client here. Let's put a second client. Let me bring another PC that we are going to call, for example, client 2. Let me connect client 2 to the switch. And we are going to see if we can write rules that will allow client 1, but will not allow client 2. Okay, so let me start client 2. Let me go back to client 1 and give it the name of client 1. So it's a little easier to understand. Client 1. As you can see, say client 1. Okay, so the other one should be ready. The default name is Debian. Let me change it to client 2. Let me go out and come back. Okay, so what is the IP address of client 2? So let me copy it, and we are going to make it easier. we are going to write it here. So when we see the graph, we know the IP address. So this is the IP address of client 2. What is the IP address of client 1? So let me get the IP address of client 1 with the command ifconfig. So this is the IP address of client 1. Let me put a small label here to help us. So this is the IP address of client 1. And I need the IP address of the server. So let me go to the server here and get the IP address of the server, ifconfig. This is the IP address of the server. So now let's do this exercise again. So in this moment, both machines, client 1 and client 2, can access the web server in server, the secure shell server in server. How can I prove it? So you go, for example, in client 1 and you try to secure shell, and it will be allowed. So let's do that. So we have the IP address of the server. So let me try to secure shell in the server. If I see the communication, as you can see, we can see the communication. So it is open. It's let me secure shell from client 1. Can I do it from client 2 in this moment? Yes, I can also do it from client 2. So let's try to secure shell from client 2 to the IP address of the server, which is 192.168.122.110, and it's allow the connection. Okay, so I want to only allow client 1. So let's type the rule that we say. So I'm going to go to the server and type the rule. So the rule, we don't have IP table installed. Let me see if we have it or we don't have it. Yeah, we have it. So in this moment, let me see for table filter, the 3 chains are empty. So I'm going to say, I want to add a rule to the input chain. I want only to allow client 1. So I'm going to say, what is the IP address of client 1? 192.168.122.122. So the protocol is TCP. The destination port is 22. So what do I want to do with that? I want to accept it. So if I secure shell now from what we want, only allow it from client 1. If I secure shell from client 2, it will still work because we have not blocked client 2. We have allowed client 1. So it will go, look here. Let me show you. You see from client 2, you see here we have policy accept. It has, oh, let me put numerical variables. So look at, it have accept 0 packets, the input. Now from client 2, I'm going to try to secure shell. It did work, as you can see. Let me show you the rules again. Policy accept 0. I will think it should show something. Yeah, but I am in client 2. I did try to secure shell in the server. This is the IP address of the server, yes. So I should have. If I do it from client 1, they will fall here. So it will start, let me do it from client 1. Here I'm in client 1. I'm going to start secure shell. Okay, let me close it. Let's see what happened. So you see, 12. Because I tried to secure shell on client 1 and they fall here. The rule is to accept them. So now let me put the second rule in the server. So I'm going to deny all the other IP addresses. So I'm going to put IP tables dash I dash append in the input chain. I don't need to specify the source. The port is TCP. The destination port is 22. And what should I do? I should drop them. So now we will have two rules. So look at the second rule is here. So if I try now from client one, all the packet of client one will match this rule and they will be accepted because this is the IP address of client one. So let me do it. Let me do a secure cell station. We create a user that is called John. So let me say I want to enter like John. So the password is John pass. And as you can see, I am the user John in server. I am in the server. Let me exit. And if I look, for example, in the server, look at that, 57 packets did match this rule and they were accepted. And the one that correspond to the other IP address, for example, the IP address of client 2, up to now we have 0 packets. Now from client 2, I'm going to try to secure shell and I should not be able. As you can see, I'm not able. So if I look at the server, this 0 will start increasing because client 2 is trying to secure shell. So look at, we have 4, which means that client 2 already tried 4 times to start a secure cell station with the server, but the firewall is dropping the packets. Now we have a 5th attempt, as you can see, because it say this rule is in 5 in this moment. Of course, the other rule is still in 57 because client 1 have not tried anymore. So as you can see, he tried 5 times before he gave up. Let me try again. You will see that from 5 it will go to 7, for example, 8. So it's trying, but the firewall is blocking its traffic. So the firewall will only allow the traffic of client 1. So as you can see, you see how fast is to do a lab with GNS3 and to verify that my rule does work or does not work. Okay, so let's see another exercise. Okay, so that was a possibility. Oh, there is a third possibility, which is, for example, this one. Look at this one with just one rule. When you use the exclamation, you say that, for example, here the match is if the source IP address is 192.168.0.20. If you put an exclamation before, it say all IP address except this one. So it negates. As in the programming language, to negate, we frequently use the exclamation. So the exclamation here is to negate. So we negate. So this match, if the source IP address is this, so the negation is that the source IP address have to be different from this one. So this is another possibility, just with one rule. Okay, so now let's see. A second exercise. Block all the outgoing traffic to 8000/8, which means that I have a computer and I don't want the people that use this computer to go toward the network 8008. All the outgoing traffic have to be blocked. How can I write a rule to do that? So IP table, it will be what? IP table. So what will be the chain? I will append to which chain? To the outgoing chain, which is the output chain. I will append what? -D for destination. I want to filter all the packets that go toward this destination network. So what else should I add there? J, drop. J for jump or action. What should I do with those packets? I need to drop them. So there is no way now from the machine that I send packet toward network 8. There is no way. So let's say that I want to practice that and say, okay, I want to practice that in the lab that you have. What do you recommend to do? For example, from client 1, I want the people that sit in front of client 1, they cannot access network that starts with 8. So look at Google. I have an IP address that starts with 8. I can ping Google. So when I apply this rule, I should not be able to ping Google. So what rule should I apply in PC1, the one that we just mentioned? IP tables dash add in the input chain the destination 8000/8. I am going to drop them. So now if I try to ping Google, destination, oh, did you see the error? So what did I do? I put input instead of output. So let me remove this rule. How do I remove this rule? I put a wrong rule. I type this. So I can do delete the first rule in the input chain, or I can just say flush all the rule, flush all the chain, or flush the input chain. No? So if I look, I come back to a brand new firewall. Okay, so let's do it again. I'm going to put in the output chain this. So let me ping again. I cannot ping. Okay, so let's see what happened. Look at, I tried to ping 3 times. They didn't match this rule and they were dropped. Let me do the ping another, for example, 5 times. So 3 plus 5 will be 8. So at the end, when I see the counter in the output chain for this rule, it has to be in 8. Okay, because it will be 5 times that I tried plus 3 that was already there. It has to be in 8. As you can see, it is in 8. Okay, let me remove this rule from the firewall. So I come back to a brand new firewall. So if I come back to a brand new firewall, you can see it's empty. I should be able to ping again. And as you can see, I can ping Google. So you see, it's simple exercise that you can practice and you can see, oh, okay, Google have an IP address that belongs to 8. Let me try to, let me see if the web server of Google also have IP addresses that start with 8. No, they don't start. But for example, in this moment, I have access to the web server of Google. So the IP address starts in 193.194.219. So I can filter the traffic and check that. Then after that, I cannot access the web page of Google anymore. Okay? Be careful because they also have IPv6. So they might go through IPv6. And if you see traffic, it's because they go through IPv6. They don't go through IPv4. Okay, let's see another exercise. So we just did this one. So, okay, that was a rule. Exercise 3. Block all kind of access from the local machine to www.ubuntu.com. So, let's see that we can access Ubuntu. How can I check that from for example, from this client, I can access Ubuntu. Give me a command that show me that I can access Ubuntu. Which command you type to verify that we can access Ubuntu? www.ubuntu.com. And then we type a command to block us. So we will not able to access Ubuntu anymore. You remember eLinks? eLinks is a web client that is text-oriented. Here we are using text. We need a web client that is text-oriented. Here I cannot use, in this machine, I cannot use Chrome. I cannot use Firefox. So it is, I don't think it is installed by default. Command not found. So we are going to install it. So apt get install eLink. Do you want to install it on the dependency? Yes, I want. So now let's do elinks --dump, for example, www.ubuntu.com. And this is the web page of Ubuntu. So it was able to bring the web page of Ubuntu. Okay, I might, if I want to go interactively, I don't put the dump, I put that. And it brings the web page of Ubuntu. So if you go, you will see that it shows something like that. So we can go to just verify, but we already did that. And we verify it with, for example, the one of JSU, ubuntu.com. So we should have something that say, for example, enterprise developer community download is there. So it just show it like that. This OpenStack might be in some place here. Maybe in product. Okay, okay. As you can see, it can do it, no? Or OpenStack Kubernetes desktop, it might be here. Okay, as you can see, we can access Ubuntu because eLink did show us that we can access Ubuntu. Let me go out. So now I want to type a rule that will block the access to Ubuntu. What do you think we can write? And just the access to Ubuntu, which means that I should be able to go to Google. For example, if I go to Google, here it is. So it's the search engine. So there is a search field here. So you can type something in the search field, no? Now I'm in the search field, so I can type what I want to search. Okay, so let me go out and maybe just say, when I use it, I'm going to use always the --dump. Okay, this is the proof that I can access Google. Okay, Google show me that. Okay, so how I can block Ubuntu and allow access to any other site through HTTP, for example. I want to block Ubuntu totally. What you will write?
You append an output to the destination IP.
So give me the rules. So first, let's see that we start with a brand new router. There is nothing inside the router, as you can see. There is no rules. The input is empty, I have no rules. The forward chain is empty, I have no rule. And the output chain is empty, I have no rules. Okay, so I want to block the traffic toward Ubuntu. Any kind of traffic toward Ubuntu. Okay, so I need to append a rule. Where? In which chain? In which of the three chains? In the input chain, in the forward chain, or in the output chain? Who generates the traffic? And the traffic go toward who? The traffic go toward www.ubuntu.com. Who generates the traffic? This machine. I want this machine not be able to generate traffic toward Ubuntu. So it will be in which chain? In the output chain, thank you. Yes, it will be in the output chain. Okay, so what should I write after that? Correct, destination. And what should I write? Okay, we can write that ubuntu.com. And what else? Correct, that J drop. So now we should not be able, we should still be able to do that. So let's do it, and it's successful. Now, if we try to do Ubuntu, it should not work. Ubuntu, and look, doesn't work. So I cannot now access the web server of Ubuntu. As you can see, it's trying, and it will give up at one point. Let me Control-C that. It will take some time. So let's see the rules. And look, it have include 1, 2, 3 rules. Why do you think that it have include 3 rules? I just put 1 rule, and it include 3 rules. Oh, by the way, let's do numerical. It's why I like numerical. Numerical verbose. Okay, it have include 3 rules. I cannot access this destination, this one, and this one. So why you think I put www.ubuntu.com, and there are 3 rules now. Exactly. What happened that Ubuntu, of course, have a lot of traffic. So Ubuntu don't have only one web server. Ubuntu has several web server. And one have this IP address, 185, 125, 190, 20. Another have this IP address, and the third one have this IP address. So what does Ubuntu do? Load balancing. Millions of people try to access at the same time the server of Ubuntu. So when they receive the petition, some go to the first web server, some go to the second web server, and some go to the third web server. So we don't overload one machine. There are 3 machines. So there are 3 machines. So you are right. If we do a DNS query for www.ubuntu.com, it should come back with several IP addresses. How can I do a DNS query? What tools can I use? So there are several. One is called NSLOOKUP. Ubuntu.com. And look, it tells me they have this IP address, which is the one that appear. They have this IP address. This is the one that appear. And this IPv4 address, this is the one that appear here. So another tools, NSLOOKUP for name server lookup. There is a tool that is called dig. So dig say, I have another way to present the result. They have this IP address, and this IP address. So it's why 3 rules appear. I put a name, the name was resolved into 3 different IP addresses, so it put 3 rules to be sure that any of the 3 ones that the load balancer will send me, I will be blocked. Okay? So how do I unblock it? I can remove the rules. So look at the rule. The rules is, we have 3 rules. So we can flush. How do I flush? If I want to flush, I can flush the output. It will remove the 3 one. Or I can say delete, for example, in output. If I delete the second rule, let's delete the first rule. It will delete the one that have IP address 20. So let's delete the first rule. And let's see it. So you see the 20 have disappeared, and the 21 that used to be the second rules now is the first rule. On the 29 is still the second rule. So if I want to remove the 29, I'm going to remove the second rule. And I still have the first rule, the 21. If I want to remove the 21, I need to remove the first rule. And now I don't have. I have a brand new firewall, so I can do another exercise. Okay? So let's go to another exercise. So you see with those small exercise, we can learn a lot. Okay, we just did that. Okay, so those are our possibilities. Exercise 4. Block all SMTP traffic to this computer from 10.00, 17, 71, 72, and 73. So let's do it in client 1, or let's do it in server. Let's do it in server, that's fine. So here I have a server. Let's say that I have a mail server. Or to make it easy, because we already have a secure shell server, we want to block secure shell access to 4 IP addresses. What should we write? What will be the rule that we need to write? Want to block the access? Okay, let's skip this. We are not going to practice this. Let's skip this. I want to block the simple mail transfer protocol, which is port 25. I want to block it from these remote devices. So what should I write? Append in the input, yeah, because it's toward me. So source. So 10.00. What do you think? 70? What else? So let's write several possibilities. We can do that. A list that is comma separated. So we can do 10.0071, 10.0072, and 10.0073, and 10.0073. What else? .70/30 will not work. Why? This network does not exist. The one that is 68. 68.68/30 do exist. Why? So I say that 10.000, oh, sorry, 68-30 exists. And here we have 4 IP addresses that are 10.0.068. We have 69, 70, and 71. So we have that from 68 to 71. But there is no network 10.0.070. That does not exist. /30. It does not exist. Why? So the /30 network have to be multiple of 4, the last byte. So 70 is not a multiple of 4. 68 is a multiple of 4. So the 68 network exists. We have to go by step of 4. So .0, .4, .8, .12, .16, .20. We keep going. So we will have, for example, .40, 44, 48, 52, 56, 60, 64, 68, 72. So we do have 68, we do have 72. We don't have 70. That's why they choose those numbers. Because if 70 did exist, that would be fine, say, to say /30, but we cannot do that. So what can we do here? So we can put a list where we separate the IP addresses with comma. And what else is missing here? Dash protocol So SMTP use UDP, use TCP, or use ICMP? Use TCP. And what should I add at the level of port? Source port or destination port? It's come toward me. I am the one that have port 25 open because I have a mail server. So it will be the destination port, okay? Destination port is 25. So what should I do with them? Drop them. Okay, so this line, IP table is going to replace it for you with 4 lines, which is this one. It's going, even if you type 1 line for IP table, it will be 4 lines. So let's see, let's do the proof. I'm going to take this command, type just 1 line, and you will see that when we look at what we have inside, so up to now, we do have rules. Let's start with a brand new firewall. So I'm going to flush everything. So we don't have rule. Okay, let me type this rule. Just run something that look like run rule. Okay, I see that we have to change the terminal so we can see the whole rule when I type it. Okay, let me copy it again. Copy, paste in the server. What is happening here? I did something. Oh, I put it in read only. Is it? Yeah. So look at the rule. I'm tapping only one rule. Let me show you now. You see there are 4 rules, was I was telling you. So we type run rule on, let me show you again. So this table is big, maybe I have to open a little more. So look at, for this source IP address on port 25, which is TCP port 25, I will drop it from this one, this one, this one. Okay, that's fine. So there is a module that is called IP range. Module IP range. Let's get some help of the module IP range. So with the module IP range, we can specify a range of IP address. So look, when you use the exclamation, is to do the inverse. You remember I told you that. So here we could have used the module IP range to do the same thing. And if we use the module IP range, we will type IP address, IP table dash append in the input chain. So we are going to put use the module IP range. And here there is a dash dash source range. So we are going to put dash dash source range. And when we use the source range, we have to put the initial IP address, because we are going to put a range dash the final IP address. Okay, so dash the protocol is TCP and the destination port is 25. And for those, I want to drop them. So we could have write this rule, this 4 rule, or the last rule. Any one of the 3 will work. Okay? So here is the solution. We could have write the 4 rules. We could have used the module IP range. Okay, so let's see now. On the server computer, verify that port 22, 23, and 80 are open. So let's do this practice. We want to have those ports open on the server computer, 22, 23, and 80. What should I do to have that on the server computer open? So if port 22 is open, what does it mean? We have a secure shell server. We do have already. If port 23 is open, what does it mean? We have a telnet server. We do have it. If port 80 is open, what does it mean? We have a web server. We didn't install a web server. So what command can I type on the server to see what ports are open? We typed this command already several times. netstat -numerical listen port. So numerical listen TCP, sorry. So we have port 22, which is secure shell, and port 23, which is telnet. If I don't put numerical, look at it, say port 22, which is secure shell, and port 22, which is telnet. But I can tell you, nobody that know about networking never look things like that. They always memorize the numbers. They know the numbers. So we work generally with numbers because many tools don't allow you write SSH. They want you to write 22. So you better learn that SSH is port 22, telnet is port 23. HTTP is port 80, HTTP secure is port 443. Okay, HTTP is not open. What can I do here to have the port 80 open? I can install Nginx, which is a web server, or I can install Apache 2. So let's install, for example, Apache 2. apt-get install Apache 2, which is a web server. Do you want to install Apache 2 on the dependency? Yes. So let's go and bring everything. So now, if I type the same command, look, secure shell is open, telnet is open, and 80 is open, which is HTTP. So from the server computer, verify that these three ports are open. On the client computer, verify that these three ports are open from in the server. So now I'm going to go, for example, in client 1. And I want you to type a command in client 1 that check that port 22, 23, and 80 are open in the web server. What command can I type? So let me go to client 1. How can I check that port 22 is open in the server? netmap, network mapper, what? -numerical -port, for example, verify if port 22 is open. In which IP address? In the IP address of the server. So 192, 168, 122, 110. It's a open. Okay, port 22 is open and it corresponds to a secure shell server. We want to verify that the telnet port is also open. The telnet port is port 23. So look, port 20 is open and it's a telnet server. We also want to check that the port 80 is open. So it's a port 80 is open and it's HTTP. We could have write 22, 23, 80. So it's a they are open, open, open. We could have write, for example, a range of ports. Check from port 1 to 1024. It will go all over the port and give me a list of the ports that are open. So let's wait until it's finished. So it say of all these ports, look at what it say. It say 1021 ports are closed of the 1024 that I interrogate, and 3 are open. So those are the only ports that my server have open. Of course, when I ask the server, show me your open port with the command that is numerical listen TCP, it just say 3 ports are open. So of course, from the client, I also see the same thing. Okay, they say after. On server, block secure shell and HTTP traffic coming from client. So I want to block secure shell and HTTP. How can I block secure shell and HTTP? So I want to block 22 and 80. So the only one that will be allowed is telnet. What command should I type on the server? So we have rules in the input chain. So we need to flush them. Okay, let's see. We don't have any rules. We start with an open firewall. So what should I type? IP table. So that will be for the server. That will be what? Outgoing traffic, incoming traffic, or forward traffic? Incoming traffic. So append a rule that will be an input rule. What should I write? Yeah, all IP address. So I want to block from client 1, client 2, from anybody. I just want to allow, I want to block the secure shell, as they say, and I want to block the HTTP. So the only one that I will allow is the telnet from any IP address, remote IP address. So dash protocol TCP dash destination port 22. Yeah, I need to do 22. It doesn't allow 22, 80. I don't think it's allowed. No, doesn't allow that. So I need to type a first rule. With this first rule, look, if I go to the client now and I ask, what are the open ports of the 3 ports? I just block the port 22. So look at it, say port 22 is filtered. I cannot secure shell anymore, but still telnet and HTTP are open. So we want also to block HTTP. So we put a second rule saying that we want also to block port 80. So now if I ask from the client, it say secure shell is blocked, HTTP is blocked, but telnet is allowed, which means that from the client now, if I try to secure shell the IP address of the server, I will not be able to do it. This is the IP address of the server. It will not work, as you can see. If I try to get information with e-links, it will not work, as you can see. Now, if I try to telnet, it will work because it's still open. Telnet, and as you can see, say, okay, give me your login and give me your password if I give it a login. Let me close the telnet session. So that's true, I did block them. So they say, from the client, verify that the traffic is filtered for these 2 ports. What can I do from the client? We already did it. We can use nmap and ask for the 3 port, and we can see, for example, that secure shell is filtered and HTTP is filtered. So what I wanted to show you that we type 2 rules. Let me show you the rules. Numerical, verbose, list. So we have 2 rules. The first rule, block secure shell, and the second rule, block HTTP. Now we could have typed only 1 rule. So let me show you a solution where we are going to type only one rule. So I'm going to flush all the three chain. I'm going to verify that I did flush them. So you see the input have nothing. Now we are going to say append, in the input chain. So there is a module that is called multi-ports and allow us to specify several ports. So destination port with S. Previously, when we wrote destination port, we didn't put S. So destination port, I want to put the 22 and the 80. And what should I do? As action, I want to drop. Multi-ports, maybe with S. Multi-port. Oh, port is, the problem is here, sorry. Oh, before I do that, I need to say the protocol is TCP and the port is this one. Okay, so let's see now. So look at it, say I'm going for the port 22 and 30, I'm going to drop them. So if we try with nmap, we will have the same result. So as you can see, the secure shell is filtered and the HTTP is filtered, but the telnet is still open. This is exactly what we wanted to do. So when we need to specify a list of port, we can use the module multi-port. Okay, let me show you other exercises before we leave. And I want you to think about them. So look at exercise, for example, exercise. Let me go to another exercise. Okay. Permit secure shell traffic on the local secure shell server from 10 a.m. to 4 p.m. So if I come early to work, it's 9 in the morning, I will not be able to secure shell in the server. And if I leave late, after 4, I will not be able to secure shell. So here we filter in range of time. We allow the traffic from 10 to 4. So of course, if people are not working in your company after 6 p.m., you want to block the traffic, because if somebody tries to access, it might be a hacker. So it's good rules that you block the traffic after office hours to protect your company. And you open it only when people are supposed to work. So at least you filter some traffic. How can I write that? Do you have any idea? With the one, we studied some rules today. So first, there are two things that I want to do, no? On weekdays, which means that, this is a solution, sorry. So on weekdays, which means that I want to allow traffic from Monday to Friday. This is when people are supposed to work. So if somebody at any time try on Saturday, it will block. Or try on Sunday, it will block. And when people are supposed to be outside the office, which is after 4 p.m. up to 10 in the morning, it will block also. So let me show you again the slides that we saw. Okay, so look at that. What are you going to put according to that? So -m time is to say I want to use the module time to have access to all those options. So if I want to say weekdays, I will put the option dash weekdays. So I will do something like that, no? I will put let's say IP table. So in the, let's see the exercise, what it say. Secure shell traffic from, okay. So it will be append in the input chain. So the protocol will be TCP. The destination port will be 22. So I'm going to use the module time. So I want to allow traffic from 10 to 4 p.m. So I'm going to put time start at 10 and then time stop at 4 p.m. Do you agree? From 10 a.m. to 4 p.m. On the week days that I'm going to allow are Monday, comma, Tuesday, comma, Wednesday, comma, Thursday, comma, on Friday. So those ones, what should I do? I accept them. This will be the first rule. So look at this rule. It says incoming traffic that is TCP traffic on port 22, which is the secure shell server, should be allowed if the time is between 10 and 4. And the day is either Monday, Tuesday, Wednesday, Thursday, and Friday. Then what should I do? I need to say all the other secure shell traffic have to be denied because this is what I want to allow. So I need another rule, a second rule. It have to be after that will say that. Drop. Do you understand? So let's say it's 5 p.m. The first rule will not do a match, but the second rule do a match. So I will drop it. Let's say it's 9 in the morning. The first rule will not do a match, but the second rule do a match. So I drop it. Remember that when the first rule don't match, I try the second rule. If it don't match, I try the third rule. I go rule by rule until I find a match. If I don't find any match, let's say that there are n rules. I try all the n rules, none did a match. I go with the default policy. And there are two big default policies as we saw. So one default policy is to allow everything and start to say what we want to deny. And another default policy is to deny everything and start to specify what we want to allow. Okay, let me stop here for firewall. I hope you learn a lot about firewall. So of course in security, there is no way that you do security without configuring firewall. You will have to configure firewall, definitely. Okay, so